back to the Cracking FAANG YouTube channel. Today we're going to be solving Leetcode problem 895, maximum frequency stack. Design a stack-like data structure to push elements to the stack and pop the most frequent element from the stack. We want to be implementing the frequency stack class, whose initializer frequency stack will just create an empty frequency stack object. We'll also have a method push, which takes an integer value and will be pushing an integer val on the top of the stack. Pop will be removing and returning the most frequent element in the stack, and if there was a tie for the most frequent element, then the element closest to the stack's top should be removed and returned. Let's think about how we might solve this problem. Read the question prompt. Now it's time to figure out how we might solve this problem. Obviously, this stack is a bit different from the normal stacks we have, where when we call pop, what we want to do is not return the value that was most recently added to the stack. We want to be popping the most frequent element in the stack. So it is a little bit different. And the way that we're going to do this is we're going to need a few variables to basically keep track of our, counts here. So we're going to need a variable to keep track of the maximum frequency that we've seen so far, because we need to be able to return items that have that maximum frequency. So we're going to need that that value, right? And for each element in our stack, we're going to need a map which maps its that item to its frequency, right? So we'll call this frequency dictionary. And what this is going to do, like I said, is it's going to take a number and it's going to map it to its frequency. Pretty straightforward. Now, multiple numbers can have the same frequency, and we're going to need another dictionary which is going to map what? So it's going to be frequency. Maybe we should just call this something else. We'll call this groups. And what groups is going to represent is going to be mapping a frequency value to a list of numbers which have that frequency value. And the reason that we need to map to this list is because when we call pop, we're going to have our maximum frequency, we have a variable for this. So what we need to do is we need to look in our groups dictionary for whatever that maximum frequency is, and then we need to return the item that was most recently added. When we add items to this groups dictionary, we're going to add them in the order that we see them, kind of like we would with a stack. So for example, if this was like 1, 2, 3, and they all had frequency 5, if we saw 1 first, then 2, then 3, when it comes to popping, we're going to pop the 3, then the 2, then the 1. And that would be how we, deal with our maximum frequency. Okay, but say we pop all of these elements from our stack, and now 5 is an empty list. Say we've just popped the 1, what do we do? Obviously, there's no longer a number that has, a frequency of 5, because we've now just popped all of these. So what we need to do is we need to decrease our maximum frequency by 1. So the max frequency, goes from 5, now it goes to 4. And what we want to do now is remember, these numbers will also be in the frequency for 4, but we won't be accessing them. So if you think about it, in order to get to a frequency of 5, if we're keeping track of the items that have a frequency of 4, all of the numbers that have a frequency of 5 will also be numbers that had a frequency of 4 before we saw another one and added them. So that's why we can decrement the count by 1, and we'll be sure that we'll actually have a dictionary. All of these numbers, 1, 2, 3, will also be in the frequency for 4, because in order to get to a frequency of, 5, they had to go through 4. Similarly, they had to start at, a frequency of 1, then a frequency of 3, then a frequency of 4, and on and on and on. So that's why we're able to just decrement our frequency once, all of the values at a certain level are basically empty, right? We've run through all of the numbers that had that frequency. Then we can simply do it by 1. Because if you think about it, if we had the counts of 1, 2, 3 with a count of 5, and we popped them from the dictionary, from the stack, then that just means that we've gotten rid of one count of them. So now the 1 will have, a count of 4 still, right? Because we got rid of 1. Same with the 2, it's going to have a count of 4, and also the 3. So that's why we're able to decrement our frequency by 1 when we've actually exhausted the entire dictionary at whatever max frequency is. So that being said, let's go to the code editor and type this up, and hopefully it should be a little bit more clear. This problem really isn't that bad once you see how it's done, and you'll be surprised at how simple and how effective of a solution you can get. So let's go to the code editor and I'll type it out. We're in the code editor, let's write this up. The first thing that we need to do is set up our init function with all of the data structures and variables we're gonna need to implement this frequency stack class. Remember that we need to keep track of the maximum frequency so that way we can easily access it when we call our pop method. So let's define a variable for that. We'll say self.maximumFrequency, and this is, frequency is going to be set to 0. Obviously we haven't seen any numbers in the init function, so it's 0. Now we need two dictionaries. The first is going to map each value to its frequency. So we're going to say self.frequency. We're just going to set up a default dict here to keep track of its frequency. And then remember that we need a dictionary to map each frequency to the numbers that have that frequency. So kind of like a reverse index here. So we're going to say self.groups is going to be collections.default dict of list, right? So each frequency will map to a list of values. So that's the init function. Let's do the push function. So we get a value here, and we're pushing to it. So that means that its frequency inside the stack will increase. So let's get this new frequency, and that's going to be equal to its old frequency plus 1, right? We're adding it, so we're just incrementing its value by 1. Great. Now what we want to do is we want to update its frequency value. So we're going to say self.frequency of this new value is going to be equal to f. And now what we need to do is actually check whether this f is now greater than our current maximum frequency. And if it is, then what we want to do is simply update the max frequency. So we're going to say self.maxFrequency is going to be the maximum of our current maximum frequency and f. Pretty simple. And then what we need to do is we need to add this new value to the new group because we've now changed its frequency. Therefore, it should be added to the next group. So if its frequency was 4, we've now incremented its frequency, it's 5. So we now want to add it to the group representing the numbers that have a frequency of 5. So we're going to say self.groups of, our value, of our frequency. And we're going to be appending the value, right? Cool. So that is your push function. Pretty simple. Now let's take care of the pop function. So for the pop function, remember that we're going to have some frequency. We'll call it frequency. And this is going to be mapping to a list of value. So this will be like val1, val2, and val3. So, we're going to look up what the maximum frequency is because we have it in our variable, which will give us, this list of val1, val2, val3. Now we need to decide which one to return. So remember from the problem statement, if there's a tie for the most frequent element, so assuming frequency is, the maximum frequency here, and there's 3 elements here, then how do we know which one to return? Well, it tells us, return the element closest to the stack's top. So since we append these values in order that we see them, basically val3 was the one that was most recently added. So remember, a stack is last in, first out. So we'd get rid of value 3 here. So the way that we're going to do this in code is we're going to say the value that we pop is going to equal to self.groups. And what we're going to do is we're going to look up whatever the maximum frequency is. And then we're simply going to pop from that list. Now, obviously, when we're popping that value from the list, we're getting rid of it from our stack, which means that we need to decrement its count overall because we're going to be getting rid of it, right? So we're going to say self.frequency of our value is going to get decremented by 1 because we're getting rid of it from our stack. Now what we need to do is we need to double check that we're actually not going to be left with 0 items in whatever self.group of maximum frequency was. So let's say our frequency mapped to a list with just 1, and we called pop on it, which means that we'd have an empty list. If we now didn't update our maximum frequency, then the next time we call pop, it would still be the same, and we would try to pop from this empty list, which is going to throw an exception because you're popping from an empty list, and that's not allowed. So we need to actually decrement our maximum frequency down by 1 in this case, and then start popping from the items that have a frequency of whatever the maximum frequency -1 was. So the way that we're going to do this, we're going to say if not self.groups of maximum frequency. So if this pop statement got rid of the last element in this list at maximum frequency, oops, this should be self.max frequency. What we want to do is we want to say self.max frequency should be decremented by 1. And the last thing that we want to do in pop is we want to actually return the value. So we're going to say return val. I'm just going to run this, make sure I haven't made any syntax errors, and it does not appear that I have. So let's submit this. And it works. Excellent. So what is the time and space complexity for our algorithm? Well, obviously in the init function, we're just setting up, variables. This part's fine. This is all big O of 1. We're just creating variables. For the push function, let's break this down line by line. So here what we're doing is we're doing a dictionary lookup. So that's going to be big O of 1. Here we're setting a dictionary key. That's also big O of 1. Here we're taking the maximum of 2 numbers. That's big O of 1. And here we are basically doing, looking up a key in a dictionary and appending to the end of a list. So everything in push is going to be big O of 1. Okay, what about pop? What are we doing in pop? In pop, what do we do? So we do a dictionary key lookup. That's going to be big O of 1. And then we pop from the end of a list, which is big O of 1 as well, because we pop from the end of it. You don't need to reshuffle the list. Then what we're going to do is we're going to basically do a key lookup and decrement a value. So that's big O of 1 as well. This check is also going to be big O of 1. Setting this maximum frequency down by 1 is also big O of 1. And then we just return the value. So pop is also going to be big O of 1. So we have constant time on that. What about the space complexity? Obviously, we need the frequency and groups dictionaries. So that is going to mean that we're going to have big O of n space, because each number will have to have its own frequency, and then each group will be containing all of the numbers. So this is going to be big O of n because it just depends on the number of items we actually put into our frequency stack here. So that is how you solve this problem. Like I said, pretty simple. There are some ways to overthink this and try to use like a priority queue and all these fancy ways, but this is actually the most simple one and really intuitive solution. I mean, if you look at the code here, this is like what, 6 lines, and that's including white space. Same with this one. It's really small. So really not that hard, pretty easy to understand. So that is how you solve this question. If you enjoyed this video, please leave a like and a comment. It really helps with the YouTube algorithm. If you want to see more content like this, please subscribe to the channel. Otherwise, thank you so much for watching, and have a great day.